The next problem before us is, it is visible on the board, you please follow it carefully. X minus y log y plus y log x dx plus x into log y minus log x dy is equal to 0. And naturally it is not in the standard form. We may have to bring it to the standard form, that is dy by dx is equal to f of xy by g of xy, where f of xy and g of xy both are homogeneous functions of the same degree. Let us try to get it. X minus y into log y minus log x, log y by x dx plus x into log y minus log x, log y by x dy is equal to 0. From this, x minus y log y by x into x log y by x into dy by dx is equal to 0 implies dy by dx is therefore equal to y log y by x minus x by x log y by x. I think I am right. It is very easy to verify. If this goes that side, the sign will be reversed, so that it is y log y by x minus x by x log y by x. And you can, if you can simplify y log y by x by denominator, log y by x will go away, leaving you y by x. X by x log y by x and x will be cancelled, leaving you 1 by log y by x, isn't it? 1 by log y by x. And we are sure that it is surely homogeneous. It is clearly, absolutely in the homogeneous form. And we shall now use the regular pattern, the regular style of simplifying it. What is the style? Y is equal to Vx, that is a standard substitution. That is the standard substitution we like to have. Put y is equal to Vx. Thereby dy by dx is therefore equal to v plus x dv by dx, isn't it? Good. With this, what happens to the new shape of the equation 1? Therefore 1 becomes, how does this become? Come on, observe that. Dy by dx is just nothing but v plus x dv by dx. V plus x dv by dx is equal to, come on, what is y by x? It's nothing but v. V minus 1 by log v. We are happy. V and v will be cancelled. Will be cancelled. What happens? This is log v dv is equal to minus dx by x. Minus dx by x. Or integral log v dv plus integral dx by x is equal to k. What is the integral of log v? Integral of log x from the formula, standard formula of indefinite integrals, or by using integration by parts, we recollect that integral of log x is x log x minus x, or x into log x minus 1. Of course, here we have log v but not log x. For log v, it is v into log v minus 1 plus log x is equal to k. That is the answer. Of course, in the place of v, we may have to replace y by x. Let us do that. Y by x into log y by x minus 1 plus log x is equal to k is, of course, the general solution. That's all. The equation looks lengthier. Yes, you may get a doubt. Oh, it's a bulkier problem. What are the steps to be? If you all followed here, will be the answer simple or not, like that? But answer is so simple, and the procedure is also so simple. No question of any type of special obstacle here. It's very, very simple problem. Please note it. You consider the next question. It is readily available on the board. X sine square y by x dx is equal to y dx minus x dy. Of course, this may you may be tempted towards you may be tempted towards this form. It is in this one of the standard forms. If xy or x square or x square plus y square can be put in the denominator, this can be used in the standard differential. But you see here, sine square y by x is there. Such things cannot be done immediately, of course. Therefore, let us try to get it converted in terms of the homogeneous differential equation. This is of degree 0. This is first degree. Total is first degree, first degree, first degree. We feel happy. It is homogeneous. Come on. This is x sine square y by x is equal to y minus x dy by dx. Am I correct? Bring that x dy by dx this side. Implies x dy by dx is equal to y minus x sine square y by x. Right? Implies dy by dx is equal to y by x minus sine square y by x. Okay. It is in the form of y by x. Surely it is homogeneous, isn't it? Let me call this equation 1. As usual, as it is converted into the standard form of homogeneous differential equation, we use the standard substitution, that is y is equal to bx. Come on, put y is equal to bx, thereby dy by dx is equal to v plus x dv by dx. Well done. What happens to the new shape of 1? Therefore, 1 implies, come on, v plus x dv by dx is equal to v plus x dv by dx is equal to v minus sine square v, isn't it? We should feel happy. V and v go away. There it is, minus sine square v. Bring it here. What happens? Minus cosecant square v dv is equal to dx by x. Minus cosecant square v dv is equal to dx by x. It's very simple. It is now thrown into the form variable separable model. Okay. Integrate it. Integral of minus cosecant square v dv is equal to integral of dx by x. What is the integral of cosecant square v? Minus cot v. But integral of minus cosecant square v is cot v. Therefore, cot v is equal to log x plus log c. What is cot v? Cot y by x is therefore equal to log x plus, oh, there has been another information given, isn't it? Therefore, instead of log c, let us have c itself. Let us have c itself. Log x plus c. Now, it is our duty to find c also, because an additional information has also been given. What is that? The curve passes through the point 1 comma pi by 4. That only remains here. We need to find c, of course, by making use of the information that the curve passes through the point 1 comma pi by 4. We shall do it now. Observe the steps carefully. I am now to remove these steps. We shall follow that last step to find c, of course, but the curve passes through 1 comma pi by 4. So, cot of pi by 4 by 1 is equal to log 1 plus c. Pi by 4 by 1 is pi by 4. Cot pi by 4 is 1. Therefore, 1 is equal to log 1 is 0. Therefore, c is equal to 1. Required curve is, required solution rather curve is cot y by x is equal to 1 plus log x. Because c is 1. Because c is 1, we could have obtained it, isn't it? Therefore, cot y by x is equal to log x plus 1 or 1 plus log x gives you the general solution. That is the problem. The next question, another simple problem, of course. The problem is so simple, but additional information is given and additional question is also given. We are not just to have the solution, but we are supposed to have the value of y when x is equal to e is substituted in the equation. So there are two items. Number one, formation of the solution. Number two, making use of the solution. We are supposed to have the value of y at x is equal to e. Let us do that. Look here, first degree, surely homogeneous. Our general pattern is put y is equal to vx. Put y is equal to vx implies dy by dx is therefore equal to v plus x dv by dx. Let me call this equation 1. Therefore, 1 becomes, what does it imply? V plus x dv by dx is equal to x by x 1, y by x v. We can cancel v and v, b and v. Therefore, dv is equal to dx by x. dv is equal to dx by x implies integral dv is equal to integral dx by x. As we could discuss in the beginning itself, the problem is so simple, isn't it? Well, integral of dv is v is equal to log x plus c. Log x plus c. Now it is our duty to have c. What is v? Y by x is equal to log x plus c. But y of 1 is 1. That is, it passes through the point 1, 1. That is, 1 by 1 is equal to log 1 plus c, implies c is equal to 1. If you place c is equal to 1, let me call this 2. 2 becomes y by x is equal to 1 plus log x. Y by x is equal to 1 plus log x, or simply y is equal to x plus x log x, or x into 1 plus log x. Therefore, y is equal to x plus x log x. Well done, we could have got y. The actual solution is y is equal to x plus x log x, but it is not enough for us. What do you want? Still, you want to have y at e. It's very simple. It's very simple. Therefore, y at e is equal to, you just substitute e in the place of x here. Y is equal to e plus e log e. What is log e? 1. Log e to the base e is 1. So, e into 1 is e. E plus e is 2e. Is 2e. So, what is the required answer? It is 2e. The value of y at x equal to e is 2e. It is available in among the options, most probably. The option is some big like that. So like that, we use homogeneous pattern. Let us now go through some more problems. Another simple question followed by a tag. He has given this information, y of 1 is equal to 1, that is the curve passes through 1, 1. It is useful to have the original equation of the curve, that is after obtaining the value of c, that is the constant of integration. And by using that, y at x naught is v. That is, by substituting what value for x, you will get y is equal to e. That is named as x naught, and that x naught is supposed to be obtained now. Let us proceed. Okay, from this you have dy by dx is equal to xy by x square plus y square. Is it homogeneous? Can we proceed in our usual way or not? You have a check. Numerator is of second degree homogeneous. Denominator is also homogeneous of second degree. We feel happy. dy by dx is equal to a homogeneous differential equation we are having. No problem. So we proceed in our usual way. What is that usual way? Put y is equal to vx. Implies dy by dx is therefore equal to v plus x dv by dx as usual. Therefore, one happens to be, come on, what changes can be made, what type of changes can be made to the equation 1? You look at, what is dy by dx? V plus x dv by dx is therefore equal to x into vx by x square plus v square x square. Automatically x square will be cancelled, so that v plus x dv by dx is therefore equal to v by 1 plus v square. And from this, x dv by dx is therefore v by 1 plus v square minus v, means v by 1. The next step, therefore x dv by dx is equal to v minus v cube by v square plus 1. v minus v cube by v square plus 1. That is equal to minus v cube by v square plus 1. v square plus 1 by v cube dv is equal to minus dx by x. So v square by v cube, 1 by v dv minus dx by x plus dx by x plus 1 by v cube dv is equal to 0. Integrate it on all this on both the sides. Integral of 1 by v log v, integral dx by x log x, 1 by v cube, integral of 1 by v cube minus 1 by 2 v square, isn't it? Minus 1 by 2 v square is equal to c. Well done. What is log v plus log x? Log vx. But vx is y, hence it is log y minus, what is v? Y by x. V square, y square by x square. 1 by v square, x square by y square minus x square by 2y square is equal to c. Stop here. This is the solution of the given equation, of course. Now, the things before us are, you have to know C first of all. How to get it? It passes through 1, 1, isn't it? It passes through 1, 1. But 1, 1 lies on it. Log 1, 0 minus 1 by 2 is equal to c. Therefore, c is equal to minus 1 by 2. Okay? C is equal to minus 1 by. Go through the steps once again. dy by dx is equal to xy by x square plus y square. We have taken usually dy by dx equal to v plus x dv by dx is equal to x into vx by x square plus v square x square. X square is now cancelled. V by 1 plus v square is remained. You have sent v to that side. So x dv by dx is equal to v by 1 plus v square minus v. It's nothing but v minus v cube. It is minus v cube by v square plus 1. And I have brought v square plus 1 by v cube this side. dv is equal to minus dx by x. V square by v cube is 1 by v plus 1 by v cube. And I have brought minus dx by x also this side. Dx by x is equal to 0. Well done. What is the integral of 1 by v? Log v plus log x minus 1 by 2v square, isn't it? What is the integral of 1 by v cube? Minus 1 by 2v square is equal to c. But log v plus log x is log vx. Log vx is nothing but log y minus v square is y square by x square. 1 by v square is x square by y square. X square by 2y square is equal to c. Well, we have used the given condition that y of 1 is 1. What is the actual meaning of that? It passes through 1, 1. Substitute 1, 1 here. Log 1 is 0 minus 1 square by 2 into 1 square is half. C is equal to minus half. Hence the solution is log y minus x square by 2y square is equal to minus half. Is equal to minus half. Or you can bring minus half this side also. Log y is equal to half into x square by y square minus 1. I've thrown x square by 2y square that side, it becomes x square by 2y square. If I take half as common factor, x square by y square minus 1, you stop. This is the solution. Now, another piece of responsibility is again on our shoulders. What is that? What work has been reminded now? We have to know x naught, at which y becomes e. At which y becomes e. So it is our duty to have x naught. Let us find it. That part only remains here to be cleared. Okay, you observe these steps. But y at x naught is e, implies x naught e lies on it. Lies on. Let me name this sum 2. So log e is equal to half into x naught square by e square minus 1. Log e is 1. Forget it. Implies 2 is equal to x naught square by e square minus 1. Minus 1 comes to this side, so that it is x naught square by e square is equal to 3, or x naught square is equal to 3e square e root 3. Is a root 3 is the right answer. A plus or minus even if you have. That is the solution. Well, my dear, even though the original differential equation looks so simple, additional question you are supposed to attend carefully. Generally, one question will be asked and one piece of information, additional information will be given. What is the use of this information? We can make use of that for finding the constant c of the solution. Of course, by making use of that c only, we will be able to attend this question. We have got x naught as a root 3. This is the question. The next question is x dy by dx is equal to y into ln y minus ln x plus 1, and y of 1 is e. Let the value of y when x equal to 1 is e. Then the solution is, he is asking us, it is one of the simplest problems. You can easily look at this. X dy by dx is equal to y into log of y by x plus 1, or dy by dx is therefore equal to y by x into log y by x plus 1. So that you can use y is equal to vx, or y by x is equal to v. Then dy by dx is therefore equal to v plus x dv by dx, isn't it? With this, 1 can be changed. How? 1 implies v plus x dv by dx is equal to v into log v plus 1. So x dv by dx is equal to v log v plus v minus v. Okay, therefore 1 by v log v dv is equal to dx by x. Integral of 1 by v log v dv is equal to integral of dx by x. You might have observed the changes here. I have written 1 by v log v as 1 by v by log v. Justly because of anticipating the benefit of using f dash v by f of v, isn't it? The derivative of log v is 1 by v. So we can make use of that result here. Hence, it is log of log v is equal to log x plus log c, let me write. So that log of log y by x is equal to log cx. Omitting the logarithmic function on both the sides, you have log y by x is equal to cx. It is not the final step. Still, there has been a piece of responsibility for us, that is to know c, to estimate c, how to calculate it. A beautiful information, a very simple information has also been given here. What is that? Y at 1 is he is saying, and that part is only remained here. Until that, the solution has been obtained. Log y by x is equal to cx. Okay, still we have to find c. Let us do that. You please note these steps. I will be going to remove these steps. But y of 1 is equal to e. What does it mean? 1 comma e lies on the curve. Lies on, let us name it sum 2. Substitute here. So that log of e by 1 is equal to c into 1 implies c is equal to 1. What is log e? E by 1 is e, log e is 1, so c is 1. Therefore, 2 becomes log y by x is equal to x, or y by x is equal to e power x, or y is equal to x e power x is the solution. We observe it. Solution is so simple, famous, x e power x. That is the answer. Let us look at the next question. It is ready for us, of course. It has been waiting for us. Let us look at, if dy by dx is equal to y by x plus tan y by x. Oh, very happy, very happy. No question of any conversion, no question of putting any steps. It is directly homogeneous. Directly homogeneous. It is in the form of f of y by x, isn't it? Okay, it is homogeneous. Hence, we can have, let me name this equation 1. Put y is equal to vx. Automatically, unnaturally, dy by dx is equal to v plus x dv by dx. Therefore, 1 becomes, how does it become? Come on. dy by dx, in the place of dy by dx, we are supposed to write v plus x dv by dx is equal to, what is y by x? It is just nothing but v plus tan v. Plus tan v. V and v will be going out. Tan v, if it comes this side, it becomes cot v. dv is equal to dx by x. This, you observe how simple it is. By integrating this, integral cot v dv is equal to integral dx by x. Okay, what is the solution? What is integral cot v? Log mod sin v is equal to log mod x plus log c. That is, log sin v is equal to log cx. Sin v is equal to cx. Implies v is equal to sin inverse cx. Y by x is equal to sin inverse cx, or y is equal to x sin inverse cx. Of course, it is the general solution. Still, two things are before us. One is you have to find C. Another is you have to find y of half. Okay, let's first find C. To find C, what information is supposed to be made use of? This information is supposed to be made use of. Therefore, 1 comma pi by 2 lies on the curve, isn't it? But call this 2. 1 comma pi by 2 lies on 2. Substitute, isn't it? Y of 1 is pi by 2. What does it mean actually? If you substitute x is equal to 1, the value of y will be pi by 2. Therefore, 1 pi by 2 is a point on it. Well, in the place of y, pi by 2 is equal to x sine inverse cx, that is c. But x is 1, you see. But x is 1. Therefore, c is equal to sine pi by 2. Sine pi by 2 is 1. Therefore, 2 becomes y is equal to x sine inverse x. That's all. Y is equal to x sine inverse x. Well, we could have got y. Even that is not enough for us. We want to have y at half. That is, substitute x equal to half and get the value of y. Therefore, if x is equal to half, then y is equal to half into sine inverse half. What do you mean by sine inverse half? It is 30 degrees or simply pi by 6. So, this is half into pi by 6 or pi by 12. So, what is the suitable answer? Pi by 12 is the suitable answer. What is the answer? Pi by 12 is the suitable answer. These steps are very, very simple, you see. Very, very simple these are. You can easily observe. The next problem, please look at that. It looks so bulkier. So bulkier. Let's try to get it simplified. And then information has also been given. What is that? Y at 1 is pi by 3. That is, the curve passes through 1 and pi by 3. It passes through the point 1 and pi by 3. We are supposed to have the solution. That is, that solution in which the constant is also found out. Okay, right. And you need not look at that. It is surely homogeneous. It is surely homogeneous of second degree in the numerator and second degree in the denominator also. Okay. Put as usual y is equal to vx. Let me call this equation 1. Implies dy by dx is therefore v plus x dv by dx. Well done. What is therefore 1 becomes? How does it become? Let us see. In the place of dy by dx, what can you write? V plus x dv by dx is equal to, what is y by x? It is v into cos y by x is cos v plus vx sin v by y vx sin v minus x cos v. Okay, this is equal to v into, let me divide both numerator and denominator with the x. What happens? Cos v plus v sin v by v sin v minus cos v. This is v plus x dv by dx is equal. And now we send this v to that side. What is going to happen? dv by dx is therefore equal to v into cos v plus v sin v by v sin v minus cos v minus v. If you take the LCM, dv by dx is equal to, LCM will be v sin v minus cos v. Observe the numerator, v cos v plus v square sin v, v cos v plus v square sin v minus v square sin v plus v cos v. V square sin v and v square sin v can be cancelled. So that dv by dx is therefore equal to 2v cos v by v sin v minus cos v. Minus cos v. Let me bring that entire expression to this side. What happens? What happens is cos v minus v sin v by v cos v dv is equal to minus dx by x. I believe that you could have understood what I could have done. I have just interchanged this so that a minus sign will be retained here, minus dx by x. Now, what is the benefit of doing all this? You just observe what is the derivative of v cos v? Cos v minus v sin v, isn't it? For that benefit only, I have just changed the sign of this expression. So that integral of cos v minus v sin v by v cos v dv plus integral of dx by x is equal to log c. Well, please notice and note down these steps so that I like to cancel them. So that the first integral is log mod v cos v plus log x is equal to log c, or v cos v into x is equal to c. V cos v into x is equal to c. What is vx? Vx is nothing but y. Y cos y by x is equal to c. But 1 comma pi by 3 lies on it. Therefore, pi by 3 into cos pi by 3 by 1 is equal to c. What is cos pi by 3? Cos 60 degrees is half into pi by 3 is of course pi by 6, implies c is equal to pi by 6. Hence the answer is therefore y cos y by x is equal to pi by 6 is the answer. Well, my dear, even though the problem looks bulkier, by the substitution y is equal to vx of this pattern, particular pattern, it will be comfortably simplified so that to have the answer. Even though it looks bulky, see, think of the integrals here. They're standard, they're simple, they're evident, they're clear, they are ready to be used here. Yes, this is the greatness of this method. The next question before us is dy by dx is equal to y by x minus root xy. He has asked just the general solution, nothing more than that. So it's very simple. Let us make an attack directly. Do you believe that it is homogeneous? Surely, of course. First degree, x first degree, y first degree, xy product second degree, but root xy first degree again. Hence it is surely homogeneous. Okay, put y is equal to vx, and according to the pattern, dy by dx is therefore equal to v plus x dv by dx. Therefore, 1 becomes, how does it become? What is dy by dx? V plus x dv by dx is equal to, y means vx by x minus root xy is root x into vx. X into x, x square, root x square, x I divide both numerator and denominator with x. So that what is going to happen? V by 1 minus root V will be remained. So V plus x dV by dx is therefore equal to V by 1 minus root V. And you send V to that side, what is going to happen? We shall observe. Therefore, x dV by dx is equal to V by 1 minus root V minus V. This is equal to V minus V plus V root V by 1 minus root V. So V and V of course will be cancelled. Okay, so you bring that side, that expression this side, root V minus 1 by V root V dV is equal to minus dx by x. This can be split into two parts. Root V by denominator, root V and root V will be cancelled. 1 by V dV minus 1 by V root V dV plus dx by x is equal to 0. Straight integration, nothing more than that. What is integral of 1 by y? V is nothing but log V. 1 by V root V. We could have got 1 by x root x. What is the integral of 1 by x root x? Minus 2 by root x, isn't it? What is the derivative of 1 by root x? Minus 1 by 2x root x. If you multiply that with minus 2 by root x is 1 by x root x, isn't it? So for 1 by V root V, the integral is minus 2 by root V, isn't it? So plus 2 by root V, already minus is present here, plus dx by x, it is log x is equal to c. What is log V plus log x? Log Vx. But what is log V? Log V is nothing but log y. Log y. What is V? Y by x. Root V, root y by root x. 1 by root V, root x by root y. Hence it is log y plus 2 root x by root y is equal to c is the answer. Observe the next question. Here also just the general solution is only required. No question of obtaining c of the integration or any other new value. No additional question, no additional information, nothing at all. Okay, right. We are just to have the general solution only. Well done. What is dy by dx from this? Dy by dx is equal to y into y plus x by x into y minus x. Okay, call this one. Put y is equal to bx. Are you sure of it? Is it homogeneous? Of course, correct. This is of second degree, this is of second degree. Both are of the same degree, hence it is surely homogeneous differential equation. Hence, put y is equal to vx. Therefore, dy by dx is equal to v plus x dv by dx. Therefore, 1 becomes, how does it become? V plus x dv by dx is equal to vx into vx plus x by x into vx minus x. If you can get x out, it becomes x square. If you can get x out, it becomes x square. X square and x square will be cancelled. So that v into v plus 1 by v minus 1. This is your v plus x dv by dx is equal to, isn't it? Okay. Therefore, x dv by dx is equal to v into v plus 1 by v minus 1 minus v. What is the LCM? B minus 1. What about the numerator? V square plus v minus v square plus v. We should feel happy. It is 2v by v minus 1. and bring it here so that it becomes v minus 1 by 2v dv is equal to dx by x. Straight and simple. And I like to integrate directly so that v by 2v is 1 by 2 minus 1 by 2v dv is equal to dx by x. Let me take half as a common factor. For this integral is v minus log v is equal to log x plus log c by 2. Let me write. Multiply throughout by 2. What happens? V minus log v is equal to 2 log x plus log c plus log c. From this we have v is equal to log v x square c. How does it become? If minus log v is sent to that side, it becomes plus log v. It is log x square and log c, so that v is equal to log vx square c. Okay, what is v? Y by x. Y by x into x square is xy. Therefore, the next part of the solution is, I like to write here, v means y by x is equal to log of xyc. Am I right? V is y by x. Y by x into x square is xyc, or y is equal to x log cxy. No information has been given to obtain the constant c. That is why we just leave the answer like that only. That is the final shape of the answer. Y is equal to x into log of cxy becomes the solution. Yes. The next question is dy by dx is equal to y square minus 2xy minus x square by y square plus 2xy minus x square. Of course, here also the problem looks so bulkier, and there has been given another information also, that is y at minus 1 is 1. Then the solution represents, he has given some options: straight line, circle, parabola, ellipse. Only one answer will be correct among all of this. So we are supposed to observe the nature of the solution. By observing the nature, you will be able to decide whether it represents a straight line or a parabola or a circle or an ellipse. Okay, let us see. Second degree, no problem at all. Put y is equal to vx implies v plus x dv by dx is equal to dv by dx. Let me call this 1. Therefore 1 becomes, how does this become? V plus x dv by dx is equal to v square x square minus 2x into vx minus x square by v square x square plus 2x into vx minus x square. And we are sure x square can be cancelled both in numerator and denominator, so that it becomes v square minus 2v minus 1 by v square plus 2v minus 1. This is all v plus x dv by dx is equal to, isn't it? V plus x dv by dx is equal to. From this, x dv by dx is therefore equal to v square minus 2v minus 1 by v square plus 2v minus 1 minus v. Let us simplify this. X dv by dx is equal to v square minus 2v minus 1 minus v cube plus 2v square plus v by v square plus 2v minus 1. Well done. What happens to the numerator? This is minus 2v, this is plus v. While checking the LCM, v square minus 2v minus 1 is the first one. Minus v into v square is minus v cube. minus v into 2v is minus 2v square, minus v into minus 1 is plus v by v square plus 2v minus 1. Let us simplify it. Minus v cube, v square minus 2v square minus v square minus 2v plus v minus v minus 1 by v square plus 2v minus 1. If you can get minus out, what happens? What happens? It is v cube plus v square plus v plus 1 by v square plus 2v minus 1. And it can easily be factorized v plus 1 into v square plus 1 by v square plus 2v minus 1. This is your x dv by dx. X dv by dx. Therefore, v square plus 2v minus 1 by v plus 1 into v square plus 1 dv is equal to minus dx by x. Follow these steps. I may have to remove this. Therefore, dx by x is equal to minus of v square plus 2v minus 1 by v plus 1 into v square plus 1 dv. To integrate it, we are supposed to use partial fractions to split this as two pieces. Okay, integral of dx by x is then equal to 2v by v square plus 1 minus 1 by v plus 1. You can follow this very easily. 2v square plus 2v minus v square minus 1. 1v square will be cancelled, 2v minus 1, everything will be there. So that this is equal to log x is equal to log of v square plus 1 minus log of v plus 1 plus log c you can have. Or log x is equal to log of v square plus 1 by v plus 1 into c. You omit logarithms on both the sides, you will have this general solution, of course, by taking v is equal to y by x. It can be done, of course, by omitting the logarithms and by substituting y by x in the place of v. The next question, f dy by dx is equal to y by x plus f of y by x by f dash y by x, where of course f dash y by x is just nothing but the derivative of f of y by x. Okay, then what is f of y by x? The question looks new, but of course very simple. You can observe it. Okay, let us see. Put y is equal to vx. As usual, let me name the given equation to be some 1. Y is equal to vx implies dy by dx is equal to v plus x dv by dx. As usual. Therefore, 1 becomes, how does it become? Come on. V plus x dv by dx is equal to v plus f of v by f dash v, isn't it? Okay, f dash v by f of v dv is equal to dx by x. Finished. We have almost reached the position of climax. F dash b by f of v is one of the most standard forms, by integrating which we have log mod f of v is equal to log mod x plus log c. This is equal to log cx. Log f of v is equal to log cx. So let us omit logarithmic functions on both the sides. F of v is equal to cx. So f of y by x is equal to cx, and this is the right option. And of course, for that question given in the question paper, the option B is of course the right option. Therefore, f of y by x is equal to cx is the answer. You look at the question. There might be some confusion or an image of bulkier nature, but you see, the way of solving is very simple. Even the answer is also very simple. What is that? F of y by x is equal to cx is the answer. That is the question. Follow it carefully. The next question, he is just asking us about the general solution only. No question of any additional tags or any additional questions. Okay. X dy by dx minus y is equal to root of x square plus y square implies. First of all, it is not in the standard form. After getting it into the standard form, then you check whether it is homogeneous or not, and then we shall proceed, of course. So x dy by dx is equal to y plus root of x square plus y square implies dy by dx is therefore equal to y by x plus root of x square plus y square by x. Surely it is homogeneous because first degree. Is it first degree? Of course, root of x square plus y square. Okay, no problem, it is homogeneous. Let me name this 1. As usual, put y is equal to vx. After taking y is equal to vx, what happens to dy by dx? Dy by dx is therefore equal to v plus x dv by dx. And now get it to use in equation 1. Therefore, equation 1 becomes v plus x dv by dx is equal to y by x is nothing but v plus root of x square plus v square x square by x. This v and v can be cancelled directly. Root of x square is x can be cancelled. So that what do you have at the last step? X dv by dx is equal to root of 1 plus v square. Root of 1 plus v square. That is, dv by root of 1 plus v square is equal to dx by x. Dx by x. Let us now integrate it on both sides. Integral of 1 by root of 1 plus y square v square. Come on. Log of v plus root of 1 plus v square is equal to log x plus log c. You can understand very easily, no? And you omit logarithms on both the sides. What do you have? Log of v plus root of 1 plus v square is equal to log cx. Now you omit logarithms so that you have v plus root of 1 plus v square is equal to cx. Is cx. Or y by x plus root of what is v square? Y square by x square, isn't it? So it is x square plus y square by x is equal to cx. 1 plus y square by x square. What is that? Root of x square plus y square by x square. Root x square is x. Now you multiply with x. What happens to the final answer? Y plus root of x square plus y square is equal to cx square. And now further information is given to us, of course, to know the value of c. There ends the matter to that equation, that this answer. The general solution is y plus root of x square plus y square is equal to cx square. That gives us the answer for this question. So, in this way, we look at the methods of solving equations which are in the model dy by dx is equal to f of xy by g of xy, where both f of xy and g of xy are homogeneous functions of same degree, thereby calling the differential equation the homogeneous differential equation. Now let us turn our head towards another type of differential equations, namely non-homogeneous differential equations. Non-homogeneous differential equations, or they can also be called non-homogeneous differential equations which are convertible to homogeneous form. That will be the next heading for us.